Unit 9, Day 4, arcs and angles. So a lot of our answers are going to be in degrees. So in this section, we're going to be talking about interior angles. So the measure of angle 1, take a look at angle 1. Angle 1 is the same as the angle across from it because it's vertical. It's going to be half the sum of the arcs. So what you want to do is look across from the angle. And here we have the arc. And across from 1 is arc AD and arc BC. So angle 1 is half of the measure of arc AD plus the measure of arc BC. In the measure of angle 2, take a look at angle 2. Here is angle 2. It is across from arc AB and arc DC. So it's across from arc AB and arc DC. So if it helps, make sure you draw your arrows. So we're going to add up the arcs and take half of it. So in this problem, we are looking for an angle AED. Angle AED is here. It's on the inside of the circle. So what we want to do is point at the arcs. The angle is interior, so the angle is equal to half of arc 1 plus arc 2. So the angle is equal to half of 45 plus 109. So the angle is equal to half of 154, so the angle is equal to 77 degrees. So I'm going to go back and plug in the 77 degrees into our picture. So here we go. This angle is 77. So is the angle across from it. And the angle right next to it is supplementary. So we didn't have to find all of that. We just needed to find angle AED. And so angle AED is 77 degrees. Okay, in this problem, we're asked to find angle YWX. So from Y to W to X is this angle right here. So it's an interior angle, so I'm going to write down my interior angle formula. The angle is equal to half the arc plus the second arc. So we're going to create our arrows to point to the arcs. And we don't see any information. So now what we're going to do is we're going to find information about the angles just right next to those. And I'm going to mark that in blue. So I've marked that in blue. It's definitely not the angle that we're asked to find, but it's going to help us get to the answer. So the angle is equal to half of arc 1 plus arc 2. I'm going to point across from the angles, and so that'll give me arc YV and arc XZ. So now we have that the angle is 62 degrees. So in red, I'm going to come over here and put that this angle is 62 degrees, and this angle right here is 62 degrees. Let's see, I may need to erase some of that. So the angle is 62 degrees here, and the angle across from it is also 62 degrees. Not the angle we're looking for. We're looking for the angle right next to it. So this is 118. This is 118. So the measure of angle YWX is 118 degrees. This time we're asked to find arc C to D to E. So I'm going to highlight that from C to D to E. Okay. So the angle that goes with that is going to be 128. And on the other side, the arc that goes with that is going to be 73. I noticed that the angle crosses on the inside. So my formula is going to be angle is equal to half of arc 1 plus arc 2. So this time I'm giving information about the angle. It's 128 degrees, and it is equal to half of arc 1, which is 73, plus arc 2, which is, we don't know. What we're going to do to get rid of the 1/2, we're going to multiply it by 2, and we're also going to multiply the other side by 2. After this, we're going to apply some old-fashioned algebra, and let's see what our variable is. After doing that, we find out that x is equal to 183, so that means that this arc over here is 183 degrees. So here we have an angle that is on the circle. I'm going to put the angle right here on the circle in blue. So we notice that there is a line of tangency. If this is the case, then the measure of angle 1 is going to be half of the arc. So in red, I'm going to mark off the arc that goes with angle 1. Here's the arc that goes with angle 1. So whatever that arc is, take half of it and we'll find the measure of angle 1. Take a look at angle 2. Angle 2, I'm going to start at 2 and go around that arc. So we go all the way around. Here we go. So if we want to know what that angle is, we're going to take half of the arc. And if you notice, the measure of angle 1 plus the measure of angle 2 equals up to 180 because what do we see? A straight line. So here it says find the measure of angle DEG. So here is E. The question we want to ask ourselves with every one of these problems is where is the angle? Right now the angle is on the circle. And so the angle is equal to half of the arc. So let me fill in my given information and solve for what I'm trying to find. Okay, so here I'm looking for angle DEG. So I'm going to start at this angle and go around to see what the arc is. Here is the arc and it's given 308. So half of 308 is 154. So this angle right here is 154 degrees. So in this section, we notice that the angles are on the exterior. So this is going to be a different formula. So I'm going to tap blue on the angles that are formed outside. So here are all the angles that are formed outside. So for angle A, it's going to be half of CE. So here is the angle. Let's put an arrow across from the angle. And here are the intercepted arcs right here. So the angle is equal to half of arc CE minus arc BD. Let's take a look at angle A. For angle A, we're going to draw an arrow across from angle A. And what we find out is that angle A is going to be half of arc. Let's see what the arcs are. The bigger arc is BD and the smaller arc is BC. Let's take a look at the last one. Let's point across to the arcs. And the arcs here are BC. And the other arc is the rest of the way around BDC. Okay. So this is half of the major arc minus the smaller arc. Now, even though all of these pictures look different, because in the first case we have two secants and a secant line crosses the circle in two places. In the second one we have a secant and a tangent, so one line crosses twice and one crosses once. In the last one we have two tangent lines, so it only touches the circle once. What do they all have in common? What they have in common is the formula. The formula for finding the angle is half of the arc minus the arc. 1/2 arc minus arc. So for this particular one, we're asked to find the angle KLM. Where is KLM? Concentrate on L, and it's outside of the circle. So the first thing we want to do is when we figure out where the angle is, we're going to write the formula. Anytime it's outside of the circle, that's going to be a subtraction in between the two angles. So big arc minus small arc. So what you want to do is go to the angle, point across from the angle so that you can identify the arcs that make up the intercepted arcs that make up that angle. So the two intercepted arcs are 66, arc KM, and arc JN 140. So the angle is equal to half the big one first minus the small. Okay, so we subtract the two arcs and we get A is equal to 1/2 of 74. Therefore, A is 37 degrees. So this angle in here is 37 degrees. For this one, they're asking us to find angle ABC. So I'm going to put a dot where the angle is. Where is it? It's outside the circle. So I'm going to write my formula when the angle is outside the circle. It's 1/2 A minus A. Big arc minus small arc. So what I want to do next is I want to point across to my arcs so I can identify my arcs. And here are my arcs, 62. And the other one is, we don't know. So what we're going to have to do is figure out what goes here. So what I know is from here to here is 62. From D to arc C is 88. And so the rest of the circle should complete my 360. So I take my total, which is 360, and I subtract the other two arcs, and I find out that my remaining arc is 272 degrees. So I'm going to go ahead and write that in, 272 degrees. So now I have my two arcs. So the angle is equal to half of 272 minus 62. So this angle is equal to 105. So this angle is 105 degrees. So some students may say, well, wait a minute. If the big angle is 272, this is 272, and this little part is 62, does it make sense that this angle right here could be 105? Well, what we're doing is we're taking the difference. So we're taking 272 minus 62 and dividing it by 2. And hey, it comes out to be 105. So yes, this angle is bigger than this angle. It happens sometimes. It's not like the hypotenuse, where if the hypotenuse is smaller than the leg, we have an issue. We can have a smaller angle than the smallest arc. For this one, we're looking for angle BCD. Where is it? It's outside the circle. So anytime the angle is outside the circle, we're going to write down our formula. The angle is equal to half A1 minus A2. To make sure we understand where the arcs are, we are going to point across from the angle. And so we see that's arc BD. Let me mark it in blue. And it's also arc AC. Well, it looks like we don't have enough information. And what I do know is that I know that arc DE is 94. And the arc that's missing here is 180 degrees. So let's fill in what we know. So if this is, I don't like that color. If this is 180 degrees, and then this part right here is 67, and this part is 94, I should be able to find the measure of arc BD. So what I'm going to do is I'm going to take the fact that I know what the whole circle is, and I'm going to subtract all of the parts. So that's 180, 67, and 94. So when I add these together and subtract it from 360, I get 19. So my arc in here is 19 degrees. So I'm ready to finish my formula. Angle is equal to 1/2 the big arc, which is 67, minus the small arc, which is 19. So the angle is equal to half of 48. So the angle is actually equal to 24 degrees. So this angle out here is 24 degrees. What we're going to do now is we're going to take just a minute or two to figure out which formula goes with which problem. So here are our options for where is the angle. So first of all, you have to say, where is the angle? So if the angle is formed at the center, then the formula is the angle is equal to the arc. If the angle is formed on the circle, we call it inscribed, then the angle is equal to half of the arc. If the angle is somewhere inside the circle, let's see, somewhere inside. So take a look at this. I'm going to mark my angle in red. Then what we're going to do is we have two arcs. So we're going to do angle is equal to half, and we're going to add the arcs. Oh, I didn't give you a picture for inscribed. So if the angle is on the circle, here it is, then it's just going to be half of the one arc that's intercepted. So, last but not least, if we have a circle and the angle is formed outside, here's the angle outside, then our formula is going to be the angle is equal to half arc minus arc. So what do these all have in common? The angle is equal to the arc if it's at the center, and everything else is going to be half. So you need to know whether you're adding or subtracting. So if it's on the inside, we're adding. If it's on the outside, we are subtracting. These are the 4 formulas that you need to be able to recognize and write down when you see these type of problems. Thank you.